This naturalrefrigerants.com article is being read by an automated voice. ATMO Europe, Ecop rotation, heat pumps to help supply, heating for 7,500 residents in Meldorf, Germany. By Christina Hayes. Published December 22, 2025. Two rotation heat pumps developed by Austrian clean tech firm Ecop Technologies are set to be installed in Meldorf, Germany, as part of an upgrade to the town's district heating network, which serves around 7,500 inhabitants. Using a mixture of noble gases as their working fluid and drawing power from solar photovoltaics, the air-to-water heat pumps are expected to help decarbonize the town's heating supply, according to Casper von Moy, head of sales and business development at Ecop. The units are scheduled for installation and commissioning in early 2026. The heating network serves mostly single-family homes, schools, and other municipal buildings, as well as some industrial sites. Details of the project, known as Wärmewende Meldorf, Meldorf Heat Transition, were presented by von Moy at the ATMO Europe 2025 Summit, together with Joris Zimmermann, Research Associate at Steinbeis Innovation Centrum Energy Plus, which has served as the project's scientific advisor. ATMO Europe 2025 took place November 24th to 25th in Padua, Italy, and was organized by Atmosphere, publisher of naturalrefrigerants.com. System architecture. Once operational, Ecop's heat pumps will form part of an integrated multi-source heating network that also includes a solar thermal installation, an existing biogas-fired combined power and heat plant, CHP, and waste heat recovered from an existing natural gas-powered industrial printing facility. Depending on demand, heat from any of these sources can be supplied directly to the district heating network or stored for later use in a newly constructed 45,000 cubic meters, 1.6 million cubic feet, pit thermal energy storage, PTES system. The PTES, currently the largest of its kind in Germany, according to Zimmermann, can also serve as a heat source for the rotation heat pumps during winter when ambient air temperatures are low. The two heat pumps can operate either in parallel, maximizing available thermal output, or in series when higher temperature lifts are required to meet supply temperatures, Zimmermann explained. The district heating network operates with supply temperatures of 70 to 80 degrees Celsius, 158 to 176 degrees Fahrenheit, and return temperatures of 50 degrees Celsius, 122 degrees Fahrenheit. Around 610 kilowatts, 173 tons of refrigeration, and heating capacity is provided by the CHP plant at 85 degrees Celsius, 185 degrees Fahrenheit, while 800 kilowatts, 227 tons of refrigeration, of heat is recovered from the printing facility at 80 degrees Celsius. The supply temperature and capacity of the Ecop heat pumps have not been specified. Municipal leadership. The Wärmewende Meldorf project faced significant technical and commercial challenges, noted von Moy. Construction of the PTES system was complicated by marshy ground conditions, low soil stability, and high groundwater levels, requiring the use of high-performance membranes to retain water and limit thermal losses. Long development timelines, including around 3 years for planning and permitting, combined with high inflation in 2022 and 2023, led to rising costs, particularly for the PTES. The project was further challenged by the low density of heating lines in the town, putting additional pressure on capital costs. There was a point when the project was at risk, and it was the local council that really solved its problems, he said. They were involved in an absolutely exemplary way from the beginning, and they will play a critical role in the operation. The local council provided long-term loans, established a municipally owned energy supply company to operate the system, and secured public buildings such as schools as anchor customers. Public information campaigns and an innovation partnership framework were also used to ensure local acceptance and buy-in, and to maximize regional value creation. This was a huge project, and its realization was only possible through the collaboration of many dedicated partners, said von Moy. We hope that it will be a kind of example for a possibility to decarbonize local heating systems, particularly rural applications. Unconventional heat pump design. Ecop's rotation heat pumps are based on an unconventional thermodynamic cycle that makes them particularly well-suited to complex district heating applications, according to von Moy. The heat pumps are designed for flexible operation, allowing them to run in various configurations and to switch between different heat sources depending on seasonal conditions and system demand. The units can operate with high temperature glides up to 40 Kelvin on the source side, enabling efficient heat extraction. In the Wärmewende Meldorf project, it will enable the system to maintain thermal stratification within the PTES, he noted. The heat pumps can also achieve temperature lifts of up to 100 Kelvin, ensuring reliable supply temperatures across operating conditions. For its refrigerant, Ecop's heat pump uses a mix of natural noble gases, argon, R740, krypton, R784, and xenon, R7131, which are non-flammable, non-toxic, and free of F-gases. Its low specific heat capacity supports the high temperature lifts achievable by the system, while overall efficiency helps reduce the levelized cost of heat. The rotation heat pump compresses the working gas using centrifugal force rather than conventional compressors, with a rotating rotor operating at speeds of up to 3,800 revolutions per minute. Each unit has a nominal thermal capacity of 700 kilowatts, 199 tons of refrigeration, with larger system capacities of up to 10 megawatts, 2,843 tons of refrigeration, by deploying multiple units in parallel. In June 2025, Ecop announced that it had secured 10.5 million euros, $12.3 million in funding, to expand production of its heat pump and finalize its newly redesigned rotor for series manufacturing. This funding follows an award of up to 8.5 million euros, $10 million, from the European Innovation Council Accelerator in 2024 to support the production of its rotation heat pump technology,